world around us is never still. Objects move in different directions and at different speeds. But what do we mean by fast and slow? To measure the speed of an object, we're going to use a linear air track. The lightweight aluminium vehicle glides on top of a stream of air. It's a smooth, almost friction-free journey. Average speed is the distance moved divided by the time taken. To measure time and distance accurately, light gates are placed 1.5 metres apart and linked to an electronic timer. A beam of light shines from one side of the gate to the other. As the beam of light is broken, it triggers the electronic counter. Break the other light beam and the counter stops. For this vehicle to travel a distance of 1.5 metres, it takes 3 seconds. Average speed is distance, which is 1.5 metres, divided by time, which is 3 seconds, so the speed is 0.5 metres per second. To analyse the vehicle's speed in more detail, several light gates attached to electronic timers are placed at half-metre intervals. Now we can find out if the speed of the vehicle is the same all the way along the track. As the glider passes through the first gate, all the timers start. As it passes through the next light gate, the first counter stops. And then the second, and then the third. To travel the first half a metre, it took 1 second. Distance travelled, which is 0.5 metres, divided by time taken, which is 1 second, gives an average speed of 0.5 metres per second. The timer reads 1 second at the start of the next half metre. And 2 seconds at the end. Again, distance travelled is 0.5 metres and time taken is 1 second, so the average speed is still 0.5 metres per second. To travel the third half metre, it also takes 1 second. Once again, the speed is 0.5 divided by 1, which is 0.5 metres per second. So the average speed of the glider was constant all the way along the track. Plotting distance against time for a vehicle travelling at constant speed produces a straight line with a steady slope. A computer attached to the handlebars calculates the speed of this bike. Eventually, the cyclist is travelling at a constant speed. For speed to remain steady, the distance travelled in a given time interval must be staying the same. Increase the speed of the aluminium vehicle and the time taken to travel each distance will change. At 0.5 metres, the time from the start is 0.7 seconds. At 1 metre, the time is 1.4 seconds. At 1.5 metres, the time is 2.1 seconds. Increasing the constant speed of the vehicle produces a graph with a steeper incline. It takes less time to travel each half metre. What would happen to the time taken if the vehicle travelled more slowly? things travel at constant speed. Most are either getting faster or slowing down. During this golf swing, the speed of the club is changing. Freeze the action every 20th of a second, and the distance travelled by the club head varies. The time interval stays the same, but the distance travelled increases and then decreases. Speed is distance moved divided by time taken. If the time interval stays the same, but the distance travelled changes, the speed must be changing too. When the speed of an object increases, we say it accelerates. To investigate acceleration, a lightweight glider is pulled along a linear air track. It's attached to a tape that's weighted at one end. As the mass falls, it pulls the vehicle forward. To analyse the change in speed, light gates attached to electronic timers are placed at half-metre intervals. As the vehicle passes through the first gate, all the timers start. As it passes through the next light gate, the first counter stops, and then the second, and then the third. To cover the first half a metre, it took 1.8 seconds. The timer reads 1.8 seconds at the start of the next half metre, and 2.6 at the end. To travel the second half metre, it took 2.6 minus 1.8, which is 0.8 seconds. To travel the third half metre, it took 3.3 minus 2.6, which is 0.7 seconds. Plotting a graph of distance against time produces a curve. The vehicle is taking less time to travel each half metre. Its speed is increasing. To find out what happens when the vehicle is pulled with a greater force, another weight is added. This increases the pulling force. How will it affect acceleration? To travel half a metre, it took 1.4 seconds. To travel 1 metre, it took 2 seconds. And to travel 1.5 metres, it took 2.4 seconds. Increasing the force decreases the time taken to travel each half metre. The curve is steeper. Increase the force again, make a note of the results and see how the time taken for each half metre changes. Gravity is a pulling force. It pulls everything towards the Earth. In outer space, astronauts experience very little gravity. They simply float around. Back on Earth, divers fall for a fixed distance from a highboard to the pool. But do all divers fall at the same speed? To start with, does their mass make a difference? These two balls both have a similar shape, but they have a very different mass. The plastic ball has a mass of 5 grams. The metal ball has a mass of nearly 108 grams. What do you think will happen when they're dropped from the same height? Two similar shaped objects fall at the same rate, regardless of their mass. They both hit the ground at about the same time. Mass doesn't affect the rate at which an object falls. This time the mass is almost the same, but the size is different. What do you think will happen this time? The small ball falls much faster than the large ball. The beach ball experiences greater air resistance. Air resistance is a force that's caused by friction between the moving object and particles in the air. As gravity pulls the object down, air particles push against it. So which will fall to the ground first, a feather or a ball bearing? They're held at the top of a glass tube by an electromagnet. But pump all the air out of the tube to create a vacuum and see what happens. In a vacuum, there are no air particles to push against the objects, so the ball and feather fall at the same rate. Dropping a melon off a tall building gives us plenty of time to look at the effect of gravity in air. After 1 second, the melon has fallen 5 meters. But in the next second, the melon falls a further 15 meters. The speed of the melon is changing. The force of gravity causes it to accelerate at a rate of 10 meters per second per second. Gravity causes all highboard divers to fall at about the same rate, so they each have the same amount of time to perform their dive. To get more time, they need to gain a bit more height by jumping upwards as well as away from the board. Accurately, light gates are placed 1.5 meters apart and linked to an electronic timer. A beam of light shines from one side of the gate to the other. As the beam of light is broken, it triggers the electronic counter. Break the other light beam and the counter stops. For this vehicle to travel a distance of 1.5 meters, it takes 3 seconds. Average speed is distance, which is 1.5 meters, divided by time, which is 3 seconds, so the speed is 0.5 meters per second. Speed of an object, we're going to use a linear air track. The lightweight aluminium vehicle glides on top of a stream of air. It's a smooth, almost friction-free journey. Average speed is the distance moved divided by the time taken. To measure time and distance, the world around us is never still. Objects move in different directions and at different speeds. But what do we mean by fast and slow? To measure the